Gravity. Everything with mass is attracted to everything else. We know this very well on the big scale of planets. It keeps the moon in its orbit. Without it, it would fly away. And on our everyday scale, when we drop something, it falls towards the center of the Earth. Yet, it's a weak force. We easily overcome the attraction of the entire Earth when we pick things up. This weakness means we don't understand gravity so well when both objects and the distance between their centers are on a small scale. On the tiniest scales, quantum physics becomes relevant. For example, an object can be in a quantum superposition in two states at once. Gravity doesn't have a quantum description. Nobody knows how it behaves on a quantum level. We must test it to find out. However, because gravity is so weak, other forces much stronger at this scale get in the way. To test gravity at this scale, we must isolate the masses from other forces in the environment and cut the other forces' communication between them. We levitate masses to isolate them and control them, placing them in a vacuum and shielding them from long-range outside forces. By controlling the motion of one isolated mass, we can see how this gravitationally affects another using ultra-precise sensing. If we can also create quantum states of motion, we can test quantum gravity.